In the digital age, we use email every day. It's how we communicate with friends, family, and colleagues. But sometimes we receive unwanted emails. These emails are called spam. Spam can be annoying. It can also be dangerous. Spam emails might contain viruses or try to steal our personal information. A spam classifier is like a helpful assistant. It helps us filter out these unwanted emails. It learns to tell the difference between good emails and spam emails. This way, we can focus on the emails that are important to us. Building a spam classifier is a fun and rewarding project. It allows us to see the power of machine learning in action. By the end of this essay, you'll be able to build your own spam classifier. Before we start building our spam classifier, we need the right tools. In the world of programming, these tools are called libraries. Think of them as collections of pre-written code that make our lives easier. We will be using Python, a powerful and easy-to-learn programming language. Python comes with a lot of libraries, but we need a few specific ones for our spam classifier. These libraries are scikit-learn, NumPy, and pandas. Scikit-learn is our machine learning library. It provides us with all the algorithms we need to build our spam classifier. NumPy helps us work with arrays and matrices, which are essential for data manipulation in machine learning. Pandas makes it easy to load, clean, and manipulate our data. We can install these libraries using pip, Python's package installer. Just open your command prompt or terminal and type pip, install scikit-learn numpy pandas. Once the installation is complete, we are ready to import these libraries into our Python script. Import pandas as PD from sklearn.model_selection, import train_test_split, from sklearn.feature_extraction.text, import count vectorizer, from sklearn.naive_bayes, import multinomial NB, from sklearn.metrics, import accuracy_score. Now that we have our tools ready, it's time to gather our data. For our spam classifier, we need a dataset of emails that are labeled as either spam or not spam. This labeled data will be the foundation of our model's learning. Luckily, there are many publicly available spam datasets. One such dataset is the Spam Assassin corpus. You can easily find and download this dataset online. Once we have our dataset, we need to load it into our Python script. We can use the pandas library to do this easily. Data =pd.read_csv, spam.csv, encoding $Latin1. This code assumes that the dataset is in a CSV file named spam.csv. We also specify the encoding as Latin1 to handle any special characters in the emails. Before we proceed, it's always a good idea to take a peek at our data print data.head. This will show us the first few rows of our dataset, giving us an idea of its structure. Now, we need to split the data into two parts, the text of the email and the label, spam or not spam, $data, text, $data, label. Now we have our data ready for the next step. Our spam classifier is eager to learn, but there's a slight problem. It only understands numbers, not words. We need to find a way to represent our email text as numbers that our classifier can understand. Here's where Count Vectorizer comes to the rescue. Count Vectorizer is like a translator between the world of words and the world of numbers. It takes our email text and creates a bag of words representation. Imagine you have a bag and you throw all the words from an email into it. The Count Vectorizer counts how many times each word appears in the bag and creates a vector, a list of numbers representing these counts. Let's see it in action. Vectorizer =count vectorizer, x =vectorizer, .fit, transform x. In the first line, we create a count vectorizer object. Then, we use this object to fit to our email text, x, and transform it into a numerical representation. This transformed data is stored back in the variable x, ready to be fed to our classifier. Section 5. Training and testing, dividing our data for better learning. Imagine you're studying for a test. You wouldn't want to read the same material over and over again, right? You'd want to test yourself to see if you've really learned the material. The same principle applies to machine learning. We need to divide our data into two sets, a training set and a testing set. The training set is like the study material for our model. It's what our model learns from. The testing set is like the actual test. It's used to evaluate how well our model has learned. Scikit-learn provides a handy function for this. Python x_train, x_test, y_train, y_test. =train test, split, x, y, test_size, $0.25, random_state, $42. Let's break this down. Now our data is divided and ready for the next step. Section 6, Naive Bayes, our weapon of choice. It's time to introduce our spam-fighting algorithm, Naive Bayes. Don't let the name intimidate you, it's actually quite intuitive. Naive Bayes is a probabilistic algorithm. It looks at the words in an email and calculates the probability of that email being spam or not spam, based on the frequency of those words in spam and non-spam emails it has seen before. Think of it like this. If an email contains the words free, money, and prize, it's more likely to be spam, right? Naive Bayes works on this principle. Let's train our Naive Bayes classifier Python classifier =, multinomial NB, classifier.fit, x_train, y_train. In the first line we create a multinomial Naive Bayes classifier. Then we use the method to train our classifier on our training data, and. Section 7. Evaluating our model. How good is our spam fighter? Our spam classifier has been trained and is ready to fight spam. But before we unleash it on the world, we need to see how good it is. This is where our testing set comes in. We'll use the train classifier to predict the labels of our testing emails. Then we'll compare these predictions with the actual labels, which we know because this is our testing set. Python y_pred =classifier.predict x_test accuracy =accuracy _score y_test y_pred print accuracy. This code does the following. 1. Uses the trained classifier to predict the labels of the testing emails. 2. Calculates the accuracy by comparing the predicted labels with the actual labels. 3. Prints the accuracy of our model. The accuracy score tells us how well our model performs on the testing set. A higher accuracy means our spam classifier is doing a good job. Section 8. Saving our hero. Keeping the spam classifier for future use. Congratulations, you've trained your very own spam classifier. But what if you want to use it later without retraining it? Well, we can save our trained model to a file. This way we can load it and use it whenever we want. We can use the library in Python to save our model Python import pickle with open spam classifier pklwb as file pickle dump classifier file. This code saves our trained classifier to a file named spam_classifier.pkl. To load our saved model later, Python with open spam classifier pklrbe as file loaded _classifier =pickle.load file. Now we have our trained spam classifier ready to be used whenever we need it. Section 9. Fighting the good fight, making our spam classifier even better. Our spam classifier is working, but there's always room for improvement. Here are a few things we can do to make it even better. Text pre-processing. We can clean our email text by removing stop words like the a, is, etc., converting everything to lowercase and performing stemming or lemmatization, reducing words to their root form. Hyperparameter tuning. Our Naive Bayes classifier has some parameters that we can adjust to improve its performance. This is called hyperparameter tuning. Exploring other algorithms. We can try other machine learning algorithms such as support vector machines, SVMs, or deep learning models to see if they perform better. The fight against spam is an ongoing battle. As spammers evolve their tactics, we need to keep improving our defenses. But with the power of machine learning, we can stay one step ahead. So keep experimenting, keep learning, and keep those inboxes spam-free.